Hi everyone, welcome to another episode of my For Bioinformatics series. In today's video, I'm going to show you how to generate bar plots like this one here, okay, in R. That's what we are going to do. So we are going to generate different kinds of bar chart, by the way. So let's actually take a look at the various bar charts we are going to generate. So we'll generate something like this. And then we're also going to add data labels like this here. I will show you how to generate horizontal bar charts like this, as well as stacked bar charts and then group bar charts. So these are the things we are going to do here. All right. So let's proceed. So for this tutorial, you need to make sure that you have R installed. Let's just check it out. You need to have R installed, and you should also have R Studio. Okay, like what I have indicated here. Now, for the commands we are going to use, okay, I've packaged everything to a single R script. So if you want that R script, you can check the description, but the download link is there. All right, but we are going to go through the commands line by line. It's going to be interactive where I type a line, I type the codes in a line, and then I explain in detail what those codes do. All right, so we are going to take them one at a time. So that's what we are going to do. So just make sure to continue watching. Now, the good thing with this tutorial is that you only need the R and then the R Studio environment. You don't need any extra R package. All right. So just make sure you have R installed and you should also have R Studio installed. Then we can proceed. So without further ado, let's start the exercise. So I will shift my R Studio and then we will continue. So when you open your R Studio, you may see something like this, or you may have already started writing some codes, but it doesn't matter anyway. What we need to do first is to come to File, and then come to New File, and then we are going to select R script, all right, because we are doing an entirely new project. Again, let me repeat. In the R Studio, go to File, go to New File, and select R script so that we have a new R script open for you. So you are going to see something like this. And then we are going to put our quotes here and then displays, okay, output that will be displayed. Okay, if there are text or numbers, they will be shown here. And then the plots themselves or visualizations will be displayed on the right hand side here. Okay, so just take notes of that. Now we are going to proceed. So we are going to start with the vertical bar charts. I think I showed it earlier, the classical bar charts. We are going to start with something like this. All right, so let's go back to R Studio and then continue. Okay, so let's continue. So first, I'll just give some comments here. Okay, so that's just to start. Okay, now we are starting with the vertical bar charts. So if you are going to generate your bar plots, of course, you need values, you need data, you need information. So let's take a look at this spreadsheet here. Okay, so let's have something like this. Just put this here. All right. So let's take a look at this spreadsheet. So here we have samples. Okay, these are sample IDs. And for each of those samples, we have their respective snip counts. Okay, so if you are going to generate a bar chart, you need the values, which is here. And also you need to make sure you have labels that will allow you to associate those bars with their respective samples, which are here. So we need to make sure this information is available to R. All right, so we need to create this. Okay, so let's go back to R and then let's start. So I'll start with the snip count. All right. So with a snip count, I have it like this. And then it's a variable. So I'll need to add that information. All right. So I have what? 17, 10, 2, 13. This is a vector, by the way. So because we have multiple values, we need to add this C to it. This is numeric. So you create your variable, bring your C, and in brackets, you specify the values. We have 4 values because we are dealing with 4 samples. So that's what we have here. Now I'll run the script, okay, or let me just say command. Okay, we are running just this line, so it's a command. Okay, so to run, you come to this side and you can click on run. This will run it, or you can use the Alt key and then enter. On your keyboard, there's the Alt, A-L-T, and then the enter key. So use both, and then the line will also be executed, or the command will be executed. So those are 2 ways you can use to execute your commands in R Studio, to be specific. Okay, so I have the snip count. All right, now I can just print it. Let's say snip count, just to make sure I have what I need. So I have them here, 17, 10, 2, 3. Okay, so that is fine. Now I also need the sample IDs. I have the values. Let's go back to the spreadsheet. I have the values. I also need this information. It's very, very important. All right. So we'll go back. So I'll say sample ID. And then again, I'll use the vector object. So this is C. Then for the sample IDs, they are characters. So they have to be in quotes. So you can use double quotes or single quotes. So double quotes, you start P001. I bring another double quote again. Okay, so this is for the first sample. That's P001. So we do same for P002. Okay, we do same for P003. And then we do same for P004. Okay, so let's all type this. Let's make sure we type them as we see. All right, so that we are on the same page. So have it like this, and then let's continue. So I have that also created. Again, I can use the print statement to say sample ID. I have them there. That is fine. Okay, so we have what we need. So now let's start the plots. Let's say plot the bar charts. So in R, if you want to plot, okay, there are different packages available, but we are using, in this tutorial, we are using the barplot function in R. It's inbuilt, so you don't need any extra package, okay? So we use barplot. That's what we are going to use. So we have our value. So let's just plot that. So if you want to generate a bar plot, you say bar plot, and we specify the values that you are plotting. So I'll say snip count. There's it. It's very, very simple and straightforward. So I'll execute the command, and then on the right side, I'll see my bar charts or bar plots, whichever one you want to call it. So I have it like this. All right. It's also possible to change the color. All right. So I'll plot again. This time I'll change the color. So we use bar plots again. We specify the value, and then we bring a command. We say color, COL, like this, equals, and you specify your color. Okay, so I'll use blue as an example. So notice they are in quotes, so it can be single or double quotes, but I'm using single quotes. You can also use double quotes. So you have it like this. And with RStudio, if you specify a color and it's valid, then it will even display, or let's say it will highlight that text for you, the text representing that color. So here we see blue. It also gives us blue, indicating this is what we are going to see. All right. So this is how we change the color. So let's execute this command, and then let's see. So now I have my plots changing. Okay, the color has changed. So I have it like this. So it's good. We can also make it brown. That's what I displayed in the slide. We can also have it like this. Okay. Now let's reverse back to blue. But feel free to change the colors as you see fit. Okay. Now we have our bar plot here. We have 4 bars, but the question is, which is which? In the spreadsheet, we have 4 samples, and these are their respective snip counts. Now, if you are presenting this to someone, then it becomes confusing because the person doesn't know which bar belongs to which sample. So it's important to add that information. So what we are going to do is to add the bar label so that we know that this bar here belongs to samples, this or this belongs to sample, this or this. So let's add that information. So we will proceed further. So let's say add bar labels. So again, we use bar plots. We specify our data. We bring our color, which is blue. And then we bring a comma. And then we say names.arg. So this is what we use to give labels to the bar that we have. So name.arg and we say equal, and then we add sample ID. We created that information here. Sample ID. So there's it. We created it. So that's what we are adding here. Okay. So now let's execute this command. Nice. So after executing, we now have the sample IDs showing. Okay. And you make sure that they are in the same order. So this one belongs to this belongs to this. So you need to make sure that they are in the same order. So the order in which you specify the data, it should be the same order in which you specify their respective labels, like this. All right, so that things move smoothly for you. So this is for the bar labels. Of course, we can still add more information. We have this bar chart, but then let's say someone wants to find out what is the meaning of the labels here. And these values, what do they represent? All right. And then there's no title. How do we add that? Okay, all these things will make our plots look visually appealing and more understandable. All right. So let's do this. We've added the bar labels. Now let's add the X and Y labels. So if we want to add X and Y labels, again, bar plot snip count. We bring our color. Name.arg, which we have already done. Comma, and then this time you add something less. Okay. So for X label, we say X lab equals. And then here you can specify what those labels represent. So they are samples. So I'll say sample. What about the Y labels? So it's Y lab equals. Those ones represent what? Number of SNPs. So we also put them like this. Okay. So you can have it like this. All right. And that'll be fine. So I'll just try to bring this here a bit that we see all of them. Okay. So the same command here, and then you add this information. Comma X lab, you specify your label, and then the Y lab, you specify what it is. Okay, so this will be for the X and Y labels. Now, if there's too much information on the line, you can just put some of them in a separate line. So after, let's say this comma, after the name.arg sample ID, the comma there, you leave it and you hit enter. Okay, when you hit enter, make sure that comma is here. When you hit enter, the rest will come to the next line. Okay, so that would also be good for you so that you avoid cramping up a single line with a lot of information. So you can have it like this, and then you can also run it. So let's execute this command. Nice. So once you execute it, you are going to see what? The X and Y label. So we have sample, we have number of SNPs. So now it's taking shape. Okay, so now at least anyone looking at this bar chart will understand, will have a general idea of what this represents. All right, so basically we have bar chart, okay, representing number of SNPs, and then we have the respective labels, okay, or samples. Okay, so here we know that sample P001, the number of SNPs is let's say 17 or around 17 or 18. Okay, you can just do some estimation here. And of course, if you have the actual data, you can pinpoint the exact value. All right. The same for these other samples. So we have them here. All right. Now let's add a title. So add a title. So if it's a title, okay, we add the same codes. And this time when we come here, we add a comma. And then we say main equals. And then you give your title. It can be in single quotes or double quotes. Let's say double quotes. Okay, and in between the double quotes, you place your title. So I'll say snip counts. You can use any title also, that's fine. So this is what we have here. Okay, so you can see gradually we have added on, we have built upon the basic bar chart, and now we have all this information, right? So this is for the title. So let's run it. And now we have that also here. You can change the title, give it your name, that's great, someone's name, or even use the Bioinformatics Coach channel, that's also fine. Okay, or tutorials. Okay, so this will be what? A vertical bar chart. Okay, so that's what we have here. Now, sometimes you may want to add data labels. Let's just check the slide I showed. We have something like this. Sometimes you may want to add data labels, the values, like this. So it's also possible to do that. So we are going to look at how to do that. All right. Now, before we do that, let's look at this initial plot here. So the initial plot we have here, we see that if you look at the y values, okay, it's up to 15, and this one extends. Okay. So we also need to correct for that. And then we also need to make sure we put the labels in such a way that they are not in the plots themselves, but outside the plots. So that means above. That means after plotting, we give the exact values above them like this. So we are adding on. So this is what we are going to do next. So let's move back to the R Studio and then work on that. All right. So now we are going to do this. We are adding data labels. All right. So for data labels, we need to do some additional tasks. All right. First, we need to correct for the range of values that are displayed or plotted. Okay. So we need to set a range for the display of these values. Okay, the X and Y values. Okay. So we need to give a range. So we will need to work on that first, and then we can continue. So I repeat, we need to set a range of values that are on the y-axis. All right. So we have to do this so that it also accommodates, also factors in the P01 value. If you take a look at the spreadsheet, we should, or let's even use the values here. I have them here. We have 17, 10, 2, 13. But here it's up to 15. Okay. We need to make sure we have that as well here. And after that, we can proceed. So if I want to add data labels, it's important to factor in the range of values that are on the y-axis. All right. So we will need to set that first. Okay. So to do that, we have to use the ylim, okay, option. That means we need to first define a y limit, okay, on the y-axis. Okay. So I'll do this. I'll first say y-axis limits. Then I'll define it. So here it's also going to be a vector. So low, high, okay, or start end, whichever you want to call it. Okay. So first 0, comma, and then I bring the upper. So this is the lower limits. This is 0, and then the upper limit. So the upper limit, we want something above 17. Okay, so that we can have 17 in, or let's say on the y-axis. Let me put it that way. So here, we are going to use this strategy. We are first going to get the maximum value for the snip count data, which is here. Let's check it out. We are going to get the maximum value, which is 17, and then add additional values. Okay, so that additional value will ensure that the 17 is on the y-axis. Okay, so to do that, it's straightforward. This is the strategy we are going to use. We will just say max snip count. Okay, so the max snip count plus or star, let's use star. Okay, that's multiplication, multiply by 1.2. okay, you can do it this way, or you can really say plus. It doesn't matter, just make sure you have a value that exceeds the maximum. Okay, so you have max snip count multiplied by 1.2. okay, so this 1.2 I got it from page, and that was also showing how to generate bar plot. I'll link that page in the description box. But the most important thing is to know that you need to get a value that exceeds the maximum value for the data that you are plotting. That's basically what this means. All right, so this is what I have here. All right, so this becomes the y-axis limit. Here we are focusing on just the y-axis. Okay, so we need something like this. All right, so now we can execute it to get it done. You can still print y-axis limit just to make sure you have it here. Okay, so we have 0, 20.04. All right, so here you could even say max snip count plus 3. That also works, but let's just keep it simple like this. Okay, so we can change it. So instead of multiply by 1.2, you can say plus 3 or plus 4. Right. So let's maintain it this way. So now we have our y-axis limit. Now we also need to first generate the bar plots. Okay, so here what we are going to do, we are going to generate the bar plot, but we are going to assign to a variable. Okay, we are going to assign to a variable. So let's say assign the bar plot to a variable. Okay, so that's what we are going to do. We are adding data labels. So for data labels, we use the text function, which requires x and y values. Okay, so the x value is what we are generating now. Okay, let me just put this here. So for data labels, we use the text function, which requires x and y values. All right, so the x value is what we are setting. Okay, so first we need to set the y limits for the bar plots or bar chart, whichever one you want to call it. All right, and then we now assign the bar plots to a variable. That's what we are going to do next. Okay, so assign the bar plots to a variable. Let's see. So to do that, you do this. Let's check it out first. That's what we are going to do. You say bar plots objects, and then we plot. So we say bar plots snip count, and then we bring the y lim. Okay, that's the y limit equals y-axis limit. We set that here, and then we bring the other information. Okay, so for example, color equals blue, or this time we can say color equals brown. Let's change it a bit. Color equals brown, comma, and then we go to a new line. We say what? Name.arg equals sample ID, comma. You can say xlab equals what? Sample ylab equals what? Number of snips, comma, and we say what? Main equals what? Snip count. Okay, so we first have to assign this to a variable. Okay, the plot itself. All right, let's just make sure everything is okay. So we have our snip count, we have our y limits, which we have set, we have our color, we have our bar labels, we have our x, y labels, we have our title. So we need to run this first to get that variable. Okay, we have it like this. All right, and then we can add the text. We'll use the text function. Okay, so I'll say text into brackets. We need x and y values. So x will be equals to the bar plot object, comma. Okay, and then the y here, the y becomes this individual bars. Okay, but then what we need to understand is that we are setting it above the bar plots themselves. So we also need to have a value, okay, or a location, okay, a point where the plots or where the labels will be indicated. Okay, we need to have a place. Okay, so that is what these are. So these are more like coordinates, or let's say the area where the plot should be. So x is for the bar plot objects, we have them, and then the y is going to be their respective values plus 1, because we don't want them to be exactly on their values. Okay, so we add an information. So we say y equals snip count plus 1, because we want them above the bars themselves, the plot themselves. So that's why we are adding plus 1. So plus 1 means the plot themselves, where the end just above it, that's plus 1. That's what we have here. So let's plot this, and then let's look at what we have. Okay, now once we have this, okay, we also need to add the labels themselves. Okay, we need to plot, but then we have x, y, we need the labels. So I'll say labels equals snip counts. So labels, we are using the respective values themselves as the labels. Okay, so that's what you have. So you need the x, you need the y, you also need the labels. Okay, the labels become the values themselves. All right, so let's run this command, and when we run it, you will see that we now have our final data here. It's looking very nice and good. So we have our bar plots. We have also added the data labels. Now the data labels themselves, so you can change the colors. Okay, so if let's say you want to use a different color, let's say blue for the labels, it's the same thing, okay, that we have here. Let's set color. So the same, but this time when we come here, we add color. You can say equals blue, and then you can run it. So this will change the color for you. Okay, so it's also possible to change the colors of the data labels. All right, so that is what we have here. Okay, so it's a cool thing that we are doing here, okay, with okay, for data visualization. All right, so let's continue the good job we are doing. Okay, so this is for what? The vertical bar. Now there are times where instead of the vertical bar, okay, the classical bar that we have here, you may want a horizontal bar, okay, like this one here. Let's take a look at the slide. All right, you may want something like this, and of course, you also want to add some information, okay? So it's possible to do that. So that's what we are going to do next. So in the next session, we are going to look at the horizontal bar charts. So let's go back to our studio, then let's proceed. Okay, so in the next section, which we are about to start, we are going to look at what? How to plot horizontal bar charts. So let's hop right into it. So again, we are going to use the same information. Okay, we are going to use the information here. So we have our samples, and these are their respective SNP counts. All right. So we are going to use that to generate the horizontal bar charts. All right. So let's proceed. So first of all, I will encourage you to make sure you revisit the vertical bar chart because we've done a lot, and then we are basically going to do everything here at once. So we are doing everything at once. So you see how that is also done. So again, let's recreate our information. So we have SNP counts. So we had what? 17, 10 to 13. Okay. That's what we had. That's what we are using. And then their respective samples. So sample ID, we have what? P001. We also have P002. We have P003. We have P004. All right, we have them here. These are the sample IDs. Make sure they are in double quotes, or if it's single quote here, there should be single quote here. So this is how it should be done. Let's run it. Of course, if you want to confirm, you can issue your print statement. So SNP count, we can print it. We see it there. If you want the sample ID, you can also print it. And now we are going to generate our horizontal bar charts. So to generate horizontal bar charts, okay, it's very, very similar to the vertical bar chart that we have here. It's very, very, very simple, okay, and very, very similar. The only difference is with one argument, one key argument. That is the major difference. Let's just plot it, okay. So there's the bar plot. Let's just go over again. So if you want to plot bar plot SNP count, okay, this is the bar plot. So for horizontal, what we do is we add this information. We say horis equals true. So there's the difference. So let's run this. So when you do it, now you see what we have here. Okay. So this is how we generate the horizontal bar charts or bar plots. Okay, so you just have to add this argument horis equals true, and then it will be generated for you. Now let's add some more information. Okay, we are going to change the color of this plot. All right, we're also going to add information. Okay, so we need to add the sample information. We need to add labels to the X and Y axis. We also need to add the title of the figure. So let's do everything here so that it becomes very, very simple. All right, so we'll do that here. So let's do it. So add labels, or let's say add more information, such as labels. Okay, so we will say bar plot SNP count, which you have created. Say horis equals true. That means we want a horizontal bar plot. Let's say color equals blue. All right, so that gives us the color. Now let's add something else. Okay, we want the sample information. So the bars, which samples do they belong to? We need to add that information. So to do that is what we add names.arg equals. Okay, and then we add that. So names.arg here, the value becomes sample ID. Okay, just as we did with the other bar chart. So this becomes how we do. So let's just run this first and see what comes up. Perfect. Now we have something like this. Okay. Now, if you have this, all right, what happens is that only two samples have been displayed. We have this and this, and it also becomes confusing whether it belongs to this or this, but we have four. We need to add them. Right? So there are a couple of strategies that you can use to add the information there to properly format it. Okay, we have it there. So what we can do in this situation is to add something else, that is to change the font size so that we can have everything. Okay, so here what we are going to change the font size, okay, of the labels here, and that will help us to get everything into shape. So let's properly format. So let's say properly format the labels. So this time what we do is that we add this information. Okay, we say comma, and we say sex.names CX. So this is used to kind of manipulate the fonts that you have. Okay, so CX sex.names is for name.arc. So we will change the font size. Okay, so you can say equals, and we say, let me just do it again. So it's equals. So let's say 0.7. Okay, and then let's run it. When you run it, you will see that the font size has changed. So now we have all the labels shown. Okay, but this font size we've changed it, so it's also good that we change the font size for this one also. Okay, so to do that, we will say cx.access. Okay, so let's do this. Let's just rerun this code. Let's add some more information to it. Okay, so this time, after the sample ID, let's hit enter so that this comes to another line. And then when we come here, okay, after the cx.names equals 0.7, let's do a comma. Let's just do it here, comma, and then let's say cex dot axis equals 0.7. Let's add that. Okay, so now it becomes also small. Okay, so that's it. Now, another strategy that you can also increase the spaces between the bars and maintain the font size. That's also possible to do. Okay, maybe that's something I'll cover later too, but that's something you can also do. All right, but for now, let's just keep this as it is, and then let's continue. Now we have this. We also need to add the X labels, Y label, and then the title. All right. So what we are going to do is that we are going to copy the same code here. And now we are going to add, comma, come to the next line. Let me just reverse it. Okay. We are going to do this. We are going to do comma, come to the next line, and we say X lab. So here the X lab becomes what? S lab becomes number of SNPs, comma, Y lab becomes sample or samples, whichever one you want to call it. All right. And then, comma, another line, and we can say main equals SNP count. All right. Now, because we change the font size for this and this, we also need to do same for the labels. So we will say comma again, and we say cex.lab equals 0.7. All right. And then we can also say, yeah, we will just maintain it as it is. All right. So let's execute this command. Perfect. So now we see them like this. Okay, so that's nicely done. All right. So this becomes our horizontal bar chart. Okay, so it's very, very simple. Okay. So again, here you can also add data labels and stuff, but that's something I'll leave to you. It's your assignment. Try that and let me know. If you have any issues or if you want additional tutorials too, you can always contact me. My email is in the description box, or you can also book a one-on-one session with me for more tutorials. Okay, so this is for the horizontal bar chart. So far we generated our own data and then we used it. Okay, but what about if the information is in, let's say, a spreadsheet or in a CSV file, and you have to read that file and then plot the bar chart? So let's take a look at something here. So this time what we're going to do is to read the information from a file and then do the manipulations and generate a bar chart. So let's proceed with that. So that means we are going to do this using a real world data. All right, let's do something like this. Or let's say slash using, or let's say plots by importing data. Okay. So here what we are going to do is to read the data from a file and then plot it. Okay, so that's what we are going to do. Okay, so let's look at this example data. So when you go to my GitHub repo, okay, I have some data sets here. So we are going to look at how to read this file, okay, and then generate a bar chart from this information that we have here. Okay. So go to this page. Okay, the link to this page is in the description box. I repeat, the link to this GitHub repo is in the description box. So use this file, snipcount.csv. .csv. So click it. So when you click it, you'll be sent to this page and you'll see something like this. So when you see something like this, what I want to do is to come to this side, raw. Okay, right click and then copy the link address. We don't need to download, we will just purchase directly from GitHub using the link address downlink. So copy the link address. All right, that's what you do. Alternatively, you can click on raw. When you click on raw, you'll see this. Okay, so just copy this one here, this information here, the link that you see here. Copy this link. That's what you need. So just copy it. Okay, and then let's go back to our studio. Okay, so we are now going to import a data and then plot from that information. Okay, so plot by importing data and then using it. Okay, so let's do this. So I'll say data file, or let's say data file link. Okay, or let's say link. Yeah, URL will be fine. So data URL equals, and then you have it in double quotes and you place your link in it. Okay, so that's how it should be. All right, you should make sure, let me just reduce the font size so that we see what I'm talking about. So we need to do this. You don't need to come here. I'm just showing you something. I just want to show you something here. Yeah, let's do this. So you need to make sure that the link that you copied, okay, it's in double quotes. Okay, so you put your double quotes and then you place the link in them. There should be no space here or here. Okay. Alternatively, you can also download and import. That's fine. But I want us to import directly from GitHub. So you should have it this way. All right, then we can proceed. So I'll just go back and then change the font size and then I'll continue. All right, so let's do this. Yeah, this should be fine. Okay, good. So now we have our URL, data URL. All right, and then what we need to do is to fetch that data. We need to fetch that data. Okay, so I'll just say df, that's data frame. And I'll say read.csv, and I'll say data URL. That's what I need to have here. Okay, so this is what we are going to use. Now here I want something else. All right, I'll say row.names equals 1. So please make sure you also do that as well. And then let's run it. All right, so when you run it, we are going to get this. Let's print df. When you print it, you are going to have something like this. Right, you see something like this. So for now, I want us to plot the data for sample 3. That's what I want us to plot. We are going to do a simple bar chart. Okay, so first of all, we need to get our data. That's the plot data. So I'll just say plot values. Okay, so to be equal to df, I need sample 3. Okay, so we need to subset that. So in my square bracket, I'll say comma, and I'll say sample 3. All right, so this will give me the plot values. Okay, if I say print plot values, I'll get what? 74027. And if you take a look at the df, let's rerun this one again. You see, we have it's like this. We have chromosome 1, 2, 3, 4. So we need to get those informations as well. Okay, so here I can even just say labels. Okay, I can even say that, let's say bar labels, and here I'll say row dot names df. All right, so I'll run this. So when I print bar labels, I should get this. Okay, so I also need this. So now what I'm going to do is to plot. I'll just redo it again. So I'll just say bar plot. I'll say plot values, comma, color equals brown, name.arg equals bar labels, comma, the next line I'll say what? Xlab equals what? Chromosome, comma, Ylab equals number of SNPs, comma, main equals SNP count per chromosome, like this. Okay, I repeat here, if you use double quotes like this, then this place should also be double quotes. Right, so you should have something like this. Okay, and then you can run it. So let's run the script, or let's say command. It is a single command. So let's run it, and then let's see. Okay, perfect. So now we have something like this. Okay, so here we've imported data, and we have used that to generate a bar chart. Okay, it's very, very simple and cool. Okay, so this is something that we need to all practice. So here we are using a real world data where we import the data from a file, and then we subset, and then we run it. Okay, so this is how we generate a bar chart. Okay, so now let's proceed. So now what we are going to do next is to generate this plot, the one here. What we are going to do next is to generate a stacked bar chart like we have here. All right, so let's get back to our studio and then continue from there. So again, we will come here, and then we will just do this. I will put stacked bar chart. That's what we are going to generate next. Okay, it's also very, very, very interesting. So let's proceed with that. So let's do this. Okay, so we are going to generate a stacked bar chart. Okay, so here we are still going to use the real world data. So let's get back to the GitHub repo here. Let's get back here. We are going to use this data, all right? This data here, that's what we are going to use. So we can see it here, all right? I think I also have it already open here. We are going to use this data, okay? So it's on GitHub. So that is where we visited recently. There's it, all right? So we are going to use this data and then generate the stacked bar chart that I showed, all right? So when you're on this page, all right, what I want to do is to come here. Let me repeat. The link to this page is in the description box. I repeat, the link to this GitHub repo is in the description box. So when you are here, come to raw and then right click and go to copy link address. Okay. Alternatively, you can click on raw. And when you click on raw, you will have this. So copy this link. I will even make it available in the description box. So just copy this link. That's what we are using. Or you can also download it. That's fine. And then just import. If you are an expert in R, that's fine. But let's keep it simple. So let's get back to RStudio and then continue. So first of all, we need to import our data. Okay, so data URL with something like this. And then you'll bring your double quote or single quotes, but let's use double quotes. So the double quote here, in between, you paste your link there like this. Okay. Alternatively, if you are not comfortable, you can still make it simple. You can just say, when it comes to data URL, you bring your first double quote like this. Okay, your first double quote, and then just after it, you paste your link. And then after pasting your link, you add another double quote like this. So this is what we are going to get. All right. I repeat, this is what we are going to get. So we will need something like this. This is how it's going to be. I'll just go back again and change the font size so that we see how it is supposed to be done. So this is how it's going to be. Let's just check it out. All right. So we'll have this. We're going to have something like this, whereby you have a single or double quote. Here I'm using double quotes, so let's keep it this way. So you have your double quote, you paste the URL link, and then after the link has been pasted, you add another double quote to close it. So this is what you should have. All right. Now I will revert back to my old font size so that the text becomes bigger for us. All right, so we have it done. Okay, so once you have it like this, then you can run the command. So this will create the URL. Let's just check here. I'll just make sure I have it here. Okay, so you run it. Yeah, so you should run it, okay, so that you have it like this, right? So now that you have access to the URL, then we can start some manipulations, okay? So we need to make the data available. Now there's the URL, we need to get the data frame itself. So I'll say df, and I'll say read.csv, and I'll say data underscore URL. I'll have it like this, comma, and I'll say row.names equals 1. So let's run this. So we have it there. Again, you can still use your df to print to make sure we have it there. So we should have your rows and columns. All right, like this. Then for stacked bar charts, because we are going to use all this information, okay, we need to make sure that we have converted this data frame to a matrix. Okay, we need to have that also done. I repeat, we need to have this data frame converted to a matrix. Okay, so we will need to, let's say, convert data frame objects to matrix. So I'll say df equals as.matrix df. Now execute it. All right, so this is what I should get. Now if you want to confirm, you can just say class df. So when you run it, it should tell you matrix array. That means we've converted it. So this is what we need. All right, so let's proceed. So now we have our input data, but then we need to add something else. All right, now if you look at the df, okay, that's what we have. We have sample 1, sample 2, sample 3, sample 4. Okay, we are dealing with SNP counts, and for each of them, we have count for chromosomes. That's what we have here. Let's get back to the chart here. Okay, so we have for each sample, we have the count for chromosomes, chromosome 1 to 4. These are the ones that have been stacked. So we also need to make sure we have a way to distinguish between these chromosomes. So this is where the colors come in. Okay, so that means we also need to define colors that will be used to assign to these groups or these subgroups, if I can say it that way. So let's get back to the RStudio, and then let's also define colors. Okay, colors that will be used. Okay, so for colors, so for colors, we define colors to be used for the chromosomes. So I'll just say colors. I'll bring this one rather. I'll say C, that's vector. And then I'll just add it. So it was green, comma. And then we have what? Orange, comma, and we have brown, comma, we have blue. All right, so these are the colors. I'll rerun it again, and I'll print again just to make sure everything is okay. Perfect. So now I have what I need. Okay, so let's just plot. So to plot the stacked, we say barplot, and then we give our inputs, which is df. All right, comma. Now when we come to names, we also need to give names. All right, so let me actually even define that also here. All right, that's important. So here when we come to samples, that's the names. So samples, okay, let's define the sample names or sample IDs. Right, let's define them here. Okay, so here let's say sample IDs or sample ID, because to call names df. All right, so we'll give this, and if I print sample ID, I should have them like this. All right, so once I have them like this, then I can proceed. So for stacked bar charts, all right, for stacked bar charts, we plot basically the same. So we say bar plots, we specify the inputs like this. Okay, now I want us to keep it simple. Let's just do this one and let's see what happens. Let's run this. Then we are going to get this, right? So this is the basic stacked bar chart that we have. And of course, we need to add some additional information and then properly format them, right? So that's what we are going to do next. All right, so we need to even check all these things first here. Okay, I'll just bring them here. Okay, so let me just do this. So you will notice that here it was something like this. Okay, sometimes in R, if you do a plot and then the samples or the labels are shown something like this, what you can do is to enlarge the display section, okay, the canvas here. So when you enlarge it a bit, things will be shown for you. Okay, or sometimes you can change the font size also. That will also allow you to have it properly displayed. So sometimes you don't need to change font size or format any of the text in there like I did previously. You can just manipulate these ones here, then you get what you want. Okay, so let's proceed. So this is the, let's say, basic stacked bar chart. Now let's add the color. So if you want to add a color, the same bar plot df, okay, like this. And then what do? You then bring comma and you say color equals colors. We have already defined it. So let's run it. So when you do it, now you have these things here. Okay. Now you will notice that the sample like this will automatically what? Shown. Okay, sample 1, sample 2, sample 3, sample 4. Okay. So it was automatically shown. So that means we don't need to manually specify the sample IDs like we define here because they are shown here for you. If they were not defined, if they were not displayed, then you can add it. But this one, we don't need to add it because it's already there, right? So that one, we will keep it as it is. Now, what else do we need to add? We need to add labels, okay, X lab, Y lab. So again, add more information. So again, the same command, by this time, comma, and we say what? Y lab equals, let's start with the X lab. Okay, so X lab equals sample, Y lab equals what? Number of snips. So for the text here, that depends on you. All right. So you can have it like this. You can also say main equals snip count per chromosome, like this. All right. Again, here I'll bring it to the next line so that it becomes readable. So you can have it like this. So let's execute this command. Nice. So now we see how nicely it has been displayed for us. Okay. Now, one more thing. We have the stacks, all right, but then which chromosome is for which? We don't know. So we need to add that information. So this is where the legends come in. Okay. So we can say add legend to display colors for the chromosomes. Okay. So add a legend. So we say legend. And then we can define where it should be. I can say top left. So that means top left. And then, comma. Then I'll add chromosomes. Okay. Now here, we do not define the chromosomes. So you can put it here. You can say row.names into brackets df. Like this. Okay, row.names, okay, into bracket df. That will give you the chromosome names. Okay. So we can do it this way. And then you can run it. So this will give you something like this. Okay. But when you do it this way too, you see, we still need to properly format them. Okay. So we have chromosomes, but where it is, it's still not okay. So we need to properly add some more information. All right. So I'll do this. I'll first define the chromosomes. All right. So I'll say chromosome and I'll say row.names df, so to give me the chromosomes. Then I'll now define it again. So add legend and properly format. I'll say legend. I say top left, that's the location, comma. I'll say chromosomes, comma. Now add a CEX equals 0.7, comma, and I'll say fill equals colors. All right, so we have them like this. So we can now execute this command. So let's run it. Perfect. Now we see what we have here. Okay. Now we see that we have both legends, this and this order, because of the behavior of RStudio. So ideally, what we should do is to create a new plot and then execute this line. All right. So what we can do is to rather add a bar plot here. And then we add a legend. All right. So we just have to run. And then we now add the legend here. Perfect. So now we have it's done nicely for us. Okay. So this is a way to create stacked bar charts. All right. Of course, when it comes to the text, you know what you want to add or want to display best. So I'll just leave that to you. Okay. So once you have the basics, you have the foundation, it becomes easier for you to add up or to do other manipulations. So this is how we generate a stacked bar charts in R. All right. Now let's proceed. So far we've generated about 3 different types of bar charts. Let's look at the last one. So let's see that one. Let's do this. So what we are going to do next is to generate the group bar charts like this one. Let me just display that here so that we see what it is. I'll show it now. So we are now going to generate a group bar chart like this, and then that will be it for this tutorial. So let's look at how we are going to generate this. So we will go back to RStudio and then proceed. All right. So we will do this now. So in RStudio, let's go back there. We will do this. Let's say groups bar charts. So this is what we are going to generate next. All right, so we are going to generate the group bar chart. So again, we need to import our data. All right, so we need to import our data. So that means we need to get the URL. All right, so again, I'll just do this. Let's go to the GitHub page that has the information. So this is the page, and I'll leave the link to this page in the description box. So when you are here, come to raw, right click, and then go to copy link address and copy the link, this link. Alternatively, just click on raw, the raw button here, click it. And when you click it, you'll be sent to this other page here. You'll see something like this. And then just copy this link. Okay, just copy this link. Okay, copy, that's all that you need. Okay, because we are importing directly from GitHub. But you can also download the data itself and then import, that's fine. All right. So once you have this, then you'll move to RStudio to do the rest of the tasks. So let's move back to RStudio and then let's get our URL. So it's data underscore URL. You assign to a variable. So again, you have your double quotes first and then you paste the link, and after pasting you add another double quotes like this. So this is what you should have. I will just do it again for you to see. So we are going to have something like this. Okay, so you should have something like this. All right, let me just change the font size so that we all see what is happening. So we have it like this. All right, so you have your data URL. You bring your symbols to make sure that R knows you are assigning to a variable. So you bring your double quotes, you paste the link and another double quotes. So this is what you should have. There should be no space between the double quotes and then this. There should be no space between this double quotes and then this. Okay, so this is how it should be. All right. Again, I'll reverse to the previous font size so that it becomes larger for you all. So I'll just do some slight changes. Okay, fine. That is fine. Okay, now we can proceed. So we have it done like this. So that means we can run. Okay, let's run this command to get a URL. I'll just run it again. Okay, that's fine. So, okay, so we have it done. Then, so here we are importing the data, right? So after that, we read the data. So I'll say df, again, I'll say read.csv. And then I'll say data underscore URL, comma, and I'll say row.names equals 1. We are going to have it like this. So let's run it, and then we can continue. So we have that done, right? So again here, we need to convert a data frame to a matrix. So we say df equals as.matrix df. Okay, so when you run it, if you want to confirm, you can say class df, and it should display matrix array here for you. So that means that it has been converted, right? So we are now going to do that. Okay, but first let me just clear this. We don't need this here. Okay, fine. Perfect. So we now need to proceed. So that's what we are going to do next. So now that we have everything we need, then we can proceed. Okay, so here what we are going to do is to still get some information. Okay, we are doing grouped. Let's just get back to the PowerPoint. All right, so we have it here like this. Okay, so for the, let's say each represents a chromosome. So it's from chromosome 1 to 4. Chromosome 1, 2, 3, 4. That's what we have here. Right? So you need to take note of that. So let's even go back to the GitHub page and then just look at what we have there. Or better, so let me just, yeah, that's what we have. So we have them like this. Let me just do this. So if you view this data in a spreadsheet software, you will have it like this. All right. So these are the chromosomes, okay, that we have. So the chromosomes are the ones that we have grouped, okay, under the various samples, okay. Hence the appearance that we see in the slide, okay, this one here. So for each sample, we have the number of SNPs counted for 4 different chromosomes 1 to 4. That's what we have here, okay. So that's what we are going to generate in this exercise. So let's get back to the RStudio and then let's proceed. All right, so now we are back to the RStudio. So what we need to do is to define colors for different chromosomes. First, let's even list the chromosomes themselves. Okay, chromosomes. So we say chromosomes. So the chromosomes are going to be the row.names df. Okay, so let's run this. Okay, so if we print chromosomes, we will see chromosome 1 to 4. All right. Now we also need to define colors. All right. So for the colors, we say colors, it's a vector. So we'll put them also here. So for colors, we need green. If it's okay, you'll see that the color, or let's say the text will be highlighted with that color, comma. We also need another color. All right, we need orange, comma. We also need brown, comma. We also need blue. Now, if it's specified, or if the colors are specified correctly, then their respective text will be highlighted with those colors, or will be highlighted with what they are going to be seen like. All right. So this is what you will see if you define the colors properly. You can use any other color, that's fine, it's up to you, but let's keep it simple here. So let's run it. Now if I print colors, all right, I should see them being displayed for me. Okay, so I'll have it something like this. So I have all the information I need. Okay, now you can also get a sample ID. So if you print df, you know, these columns are for samples. So I can define that also here. So sample IDs or sample names. So I can say sample ID or sample name, whichever one you prefer. That's a sample ID. And I can say call names df. If I run it and I print sample ID, I should get the list there. Okay, that's fine. Okay. So now we have everything we need. All right. So let's proceed. Now we are going to plot what grouped bar charts. Now with the group bar chart, the plotting is similar to the stacked bar chart. The only difference is with one argument, which I will display here. Okay, so let's say plot the group bar chart. So we are plotting the group bar chart. So to do that, we say bar plot. We specify the data, which is df, comma, and we say beside equals true. This is the main difference. So let's execute this. So when you execute this, we are going to see something like this. Okay, so this is what we need, okay, for the group bar charts. All right, so now we have it. So now we need to properly format, right? So that means we can add colors. So the same code. Okay, let's just rerun it, but this time we add cal equals what? Colors. So if you run it, we are going to get a colors, okay, that we see here. Okay, now let's add some additional information. All right, so again, let's just modify this code here. Okay, we are add more information. Okay, so here we will say comma, we come to the next line and we say xlab equals sample, comma, ylab equals number of SNPs. The text, I'll leave that to you. All right, comma, next line we say main equals SNP counts. per chromosome per sample. Again, for the text and the title, I'll leave that to you. Okay, so we have something like this. Okay, so let's execute this command. Perfect. So now we have it there. Okay, now if by any chance you want to change the IDs here, the sample IDs, then you can add something else to it. You can use the names.arg. Okay, by this time we don't need it because the information is already available in the data that we imported. Okay, but if you want to add it, it's names.arg. So you can check the first bar charts tutorial that shows how to add that information. Okay, now we have the colors, but which color belongs to which chromosome? We are still unsure. So we need to add that information. So that means we need to add a legend. All right. So to add a legend, what do we say? We say legend. We specify the location. I'll say top left, comma. I give the labels. That will be chromosomes, comma. And then what else? I say CX equals 0.7, comma, and I say fill equals colors. All right, I have it this way. So now when I run it, I'm going to get my legends. Okay, so it's so lovely and cool. Okay, so that's what we have. Okay, so that's how we generate grouped bar charts in R. Okay, so we are using just the R function barplot to do all this. Okay, so you don't need any extra package to do this. Okay, so that's what we have. All right, so you can practice. Okay, now for beginners, if you want to learn about R, I have an introductory video on R that you can also watch. That will help you to get to speed when it comes to R programming. All right, so that's it. So now I've been able to generate vertical bar charts, horizontal bar charts, stacked bar charts, and then grouped bar charts. All right, so if you want a one-on-one tutorial session, you can always contact me. All useful materials are also in the description box. So I'll see you in the next session.